Hello and welcome to Chapter 9, Sequences and Series. So we're very much changing gears from talking about different types of functions to a completely new subject where we're going to spend this unit talking about sequences and series. So starting with sequences, and we're going to talk about what that means and what we're doing with that. So let's go. So starting with some vocabulary, a sequence is an ordered list of numbers. Each number in the list is called a term. So we have a sequence and it's going to be made up of terms. So our notation is going to be A1, A2, have commas in the middle, A3, A4, and then that's going to go on until an minus 1, an. So whatever we're ending on, generally sequences don't actually end, but whatever the last one we're writing is, that would be an. And then an minus 1 is the one before that. So this could be 10 and this could be 9, right? So if you see an minus 1, that means the term before an. And we're going to be using that a lot when we talk about the next type of formula. All right, so first we're talking about explicit formulas, and that's where I want to find a certain term number. So the subscript here is always the term number. This is term 1, term 2, term 3, term 4, term n. So if I want to find a certain term number, I can just plug that number into the formula in the appropriate spot, and that will give me my term number. So if I want to find the first term, A1 is going to be 3 times 1 minus 2, or 3 minus 2, which is 1. A2 is going to be 3 times 2 minus 2, which is 6 minus 2, which is 4. So I'm just taking this number, plugging it in where it says n in the formula, and then figuring out what that's going to be. So A3 would be 3 times 3, which is 9, minus 2, which is 7. So A3 would be 7. Oh, that contrast is terrible. I'm going to write it over here. A3 is going to be 7, right? So going on, it asks us to find the first 10. So if 1, 4, it actually asks us to list the first 10. So I'm going to make a list using the ones we've already found so far. So 1, 4, 7. The fourth term, A4, is going to be 3 times 4 is 12, minus 2 is 10. A5 is going to be 3 times 5 is 15, minus 2 is 13. A6 is 3 times 6 is 18, minus 2 is 16. A7, 3 times 7 is 21, minus 2 is 19. A8, 3 times 8 is 24, minus 2 is 22. A9, 3 times 9 is 27, minus 2 is 25. And A10, 3 times 10 is 30, minus 2 is 28. So this is the first 10 terms. So you could have noticed, oh, this is linear. I can just add a 3 each time. If you notice that, that's totally fine. I'm just showing you how to use an explicit formula, how we're finding that next term. It's not always going to be that simple. So I wanted to show you the official way. All right, so let's continue on. Oopsies. I always forget that I can't click when I have the pen selected. Okay, so the other type of formula we're going to talk about is the recursive formula. So we have the explicit formula and we have the recursive formula. Recursive formula is a formula that uses the previous term. I just left off like a whole part of the word there. Okay. If you can't read my handwriting, it's written right here. Okay, so if you have a formula that uses the previous term to find the next one, that's a recursive formula. So as I pointed out on the previous slide, I could have taken, I could have said, okay, AN is just the previous one plus 3, right? So this is the notation for recursive formula. My new term is my old term plus 3. So this would be a recursive formula for the one that we did on the previous slide. So the new term is the old term plus 3, and then so in order to use this, I have to know one of the terms. So I could be given this and the fact that A1 was 1. All right, so I could be given that, and then I would be able to find the same information we found on the last slide using this information. So I'll say, okay, 1 plus 3 is 4. So my first term was 1, my next term is 4. 4 plus 3 is 7. 7 plus 3 is 10. So see how I'm always using the previous term to find the next term. So 10 plus 3 is 13. So I'm using the previous term to find the next term. So that's how recursive formulas work. You have to know the previous term in order to find the next term. So the nice thing about explicit formulas is that I can find any term. I could find term 100, and I just plug it into the explicit formula, and I just have the 100th term. But with recursive formulas, in order to find term 100, I have to know term 99. But to find term 99, I have to know term 98. You know what I'm saying? So I can't just find any term. I have to know the terms before it in order to find the next term. So sometimes having an explicit formula makes things a lot easier. And sometimes having a recursive formula can be nice too. So it really depends on the situation. And if you're looking for one of the earlier terms, having a recursive formula is fine. But if you're looking for, say, term 100, then you probably want an explicit formula for that. Okay, so we're going to keep going with some examples in the next video.